Alright, so I think I'm recording. This is part 2 of solving problems that are solving equations that are proportions. The technique we're using is to cross multiply and set the cross products equal to each other. We will multiply along this diagonal, multiply along this diagonal to take the cross product. We've got along the yellow diagonal x plus 2 times 2x plus 1. Along the purple diagonal, I have x minus 2 and 2x plus 1. So I suggest that you multiply this out in the form of a table. Or, some organized way of doing it. On the left-hand side, I get 2x squared plus 5x plus 2. If you were to do the same thing on the right-hand side, you should get 2x squared minus 3x minus 2. If I subtract 2x squared from each side, the resulting equation is 5, because these guys cancel, and I get 5x plus 2 is equal to negative 3x minus 2. Let's collect the x's on the left-hand side of the equation and the numbers on the right-hand side. Let's add 3x to both sides of this equation. The resulting equation on the right-hand side, this negative 3x and positive 3x cancel. On the left-hand side, 5x plus 3x gives us 8x. Let's subtract 2 from each side of the equation. On the left-hand side, we get the term that has our variable by itself. On the right-hand side, we have negative 4. We need to get the variable by itself, so we divide both sides of the equation by positive 8. 8 divided by 8 is 1. We recognize that 4 and 8 share a common factor of 2. That we can write negative 4 as negative 2 times positive 2, and that we can rewrite 8 at, well, no, hey, I was going to cancel out a 2 to eat. Why not cancel out the largest common factor of 4? So let's write negative 4 as negative 1 times positive 4. Let's rewrite 8 as 2 times 4, and 4 divided by 4 is 1, and our final answer is negative 1/2. Negative 1/2 is not positive 2 or negative 2. Those values would have given us zeros in the denominator, and we would have had to have thrown that solution out. So there's our answer to this one. Let's move on. So let's take x plus 3 times 3x plus 1. 4x plus 3 times x plus 1. I suggest that you multiply these in the form of a table. If you do that, you'll get 3x squared plus 10x plus 3. And here, you'll get 4x squared plus 7x plus 3. Let's collect the x's on the the x squareds, on the left-hand side. Since this is a quadratic equation, actually let's just get 0 on the right-hand side, everything else on the left-hand side, and to put it in standard form. The standard form for a quadratic is ax squared plus bx plus c is equal to 0. So if we take 4x squared from each side. The resulting equation, negative x squared plus 10x plus 3. These cancel, and I have 7x plus 3. If we subtract 7x from each side of the equation, on the left-hand side, I have negative x squared. 10x's take away 7x's is 3x's. The 7x minus 7x cancel. Let's subtract 3 from each side. Three minus 3 is 0. Three minus 3 is 0. So we have the 0 that we wanted on the right-hand side. I like to have the leading coefficient be positive, so I'm going to multiply both sides of this equation by negative 1. When I multiply the left-hand side by negative 1, that changes the sign inside the binomial for each term. This negative x squared becomes positive x squared. This adding 3x becomes subtracting 3x. On the right-hand side, 0 times negative 1 is still 0. So I'm going to look at x squared as x times x, and here, let's change my colors. I'm going to look at x as x times x, and 3, I have 3 times x. So you can hopefully see that I have a common factor to each term. So I'm going to write just the values that are in black here, the x minus, well, if I change the color to black, x minus 3, and this x get factored out of this binomial, and we can write that out in front as a single x, because remember, I can check by multiplication distributes over this subtraction at x times the first term, x times the second term, we'd get the same thing. There is a theorem in mathematics that says that if you have two numbers that multiply together to give you 0, either one or both of those numbers has to be 0. So this first factor, this x, either it's equal to 0 or this x minus 3 is equal to 0, or both, well, in this case they both can't be true, but if we add 3 to each side, so we have our two solutions. Now, let's come back. Remember that we have to make sure that we don't have extraneous solutions. We can see that x can't be at negative 3/4 and x can't be a negative 3 because they would cause division by 0, but our solutions of 0 and positive 3 are okay. We have the claim that two fractions, two ratios are equal to each other. That equation is called a proportion. Let's multiply along the yellow diagonal and along the purple diagonal. Along the yellow diagonal, we have 49x plus 5 times the quantity 2x plus 1. And along the purple, I have 5x plus 4 times 11x plus 7. So let's do this in the form of a table. If we double 49, we get 98. Or at least I hope we do. So on the left-hand side, when we multiply this out, 98x squared. And over here, if we do the same thing, we would get 55 x squared plus 30, no, 35 and 44. What's 35 and 44? 79. All right. Like I say, if you do your table, you should get the same thing. So we have a quadratic equation. Let's get it in standard form of ax squared plus bx plus c is equal to 0. Let's subtract 55x squared from each side. We have 43x squared these terms cancel. Let's subtract 79x from each side. The resulting equation, we've got 43x squared plus 20x plus 5. These terms cancel. Let's subtract 28 from each side. Five minus 28 should be negative 23. I looked here and I don't see any common factor. I'm not sure if we can factor that or not. Quadratic formula is what I would suggest that works, because we could spend a lot of time with our x method and then find out it doesn't factor. So let's use the quadratic formula. It's good practice anyway. A is equal to 43, B is equal to 20, C is equal to negative 23. Remember that the quadratic formula is a fraction where the denominator is 2 times a. The numerator has two terms, and the first term is the opposite of b. Then, rather than writing it as two fractions, we write plus or minus the square root of what they call the discriminant, which is b squared minus 4 times ac. So if we take the denominator 2 times a, 2 times 43, 86 in the denominator. The first term is the opposite of b, which is the opposite of 20. Underneath here, b squared is 20 squared minus 4 times a, which is 43, and c, which is negative 23. So my discriminant, 20 squared minus 4 times 43 times negative 23. 4356. Now, if this is a perfect square, then we could have factored it. And we could have. The numbers were just big. Alright, so let's figure out what these two numbers are. In the numerator, we've got negative 20. First I'll do the subtraction, minus 66. And that's a negative 86. And a negative 86 divided by a positive 86 is negative 1. And here On this one, if we come back and instead of subtracting, we add these together. 46, and 46 divided by 86 is what? Well, they're both divisible by 4, right? No, maybe not. That may not be divisible by 4. It is not. So they're both divisible by 2. 46 divided by 2 is 23. 86 divided by 2 is 43. And we can't simplify that any further. Let's check that against our key. Make sure I haven't made a silly mistake. What problem number was this? Number 18. One or negative 23 over 43. Did I have a negative sign? Because first I subtracted. Huh. I'm getting the exact opposite that they had. So do I have a sign error somewhere? Well,